Hey, let's get started. Wow, the resolution of the presentation is horrible. Let me fix that first. Yeah, I resized the window a little bit so I can see both, like my OBS and both my presentation. Hopefully, like yeah. So okay, I think this is better. Oops, sorry, I'm feeding back because I don't know why. Like, okay, so because I opened the dashboard on both of my other machines to monitor the chat and everything, and it just suddenly like all like yeah, all like fire up. So okay, whew, we are properly started, and I haven't checked my camera actually. Like, it's very busy this week. It's EuroPython, and so I don't know like how long would this tutorial be. It's obviously within an hour, but I will try to also make it yeah, like not too short, but also like because today we're going to talk about async. It's gonna be exciting, but yeah, I can't spend too long because I have to go back to the sprint. It's the last stage of the sprint, and it's amazing that so many people do so much contribution, and it's really good. It's a really good online conference. It's better than I thought, and I really enjoyed it, and make new friends. And yeah, I just you have to really like go to one of these conference to experience yourself, I think. Okay, so yeah, and also the stream rate is very bad. I think because I was streaming all the time for the conference, and now it's just become a little bit I think my internet is like want to say I have enough. Yeah, but yeah, I won't let it down. Like, I won't let it shut down. I won't let you guys down. So okay, yeah, I haven't slept enough, and I'm like mumbling too much. Sorry about that. I'm like super tired because I'm running the sprints. Like, I have to wake up at 7, half 7, and then usually I work till 2, and so that's like super tired for me. So we have actually go from our first episode, that is we know nothing. We start installing Python for the first time, and now we have learned so many things. We have learned all the basics of Python, so this object, how to control the flows, functions, even regex, and then we go into the testing month. We learn lots of things about testing, yeah, including property-based testing. So in the sprint this weekend, there's actually hypothesis, the library that I talk about. The maintainers, Zach is with us for when he's awake because he's in Australia. But yeah, then like you can actually work on hypothesis. That's great. Also, like we learn a little bit. So actually, I would say that in the past few episodes, we have been storytelling. We have been starting from what is an iterator, and then last time we talked about generator, and now we just going to continue our story um, from where we left off. So, and also I would do a little bit of revision as well. So once upon a time, they are generators. And then, so we learned that last time we can send information to generators. So I don't know whether I need to run this code again, but I could. I have prepared. So actually, I have not well prepared for the coding environment. I just opened a Jupyter notebook without, even creating a new file. So async, yeah. Okay, so this is generator. I'll just make some comment about it. Yeah, so yeah, just put it like this. Actually, I need to change it into a markdown. Yes. Okay. So, yeah, you see, this is what we have last time. We have this function, number generator here. And then what it does is it's basically passing information in and out. So when we create a G here, so we call next G is just like, because remember when we create a generator, it's not executing yet, so it's still kind of at the state that it is just created. And then when we call next, it would basically hit the U here, and so well, now there's nothing, so we just like enter, and then when it's the send is called, so I will accept a number here. So yeah, so you accept the number here, so 5. Okay, so and then like well, okay, it's 5, and then 5 is less than 10 because we set the n is 10 at the beginning when we initialize it. So, and then we'll come here, hit this. Okay, so let's see if, yeah, so if we run it the first time, it will be 5, okay? Because we hit the yield here, we're waiting, and then for the send, and we'll send 5 here. So okay, 5 come in, it's less than 10, so that's okay. And then I would, you know, so the number will be here and hit another yield. So this time it's come back to the print function and print out 5, okay? So this just go through this loop. So if I call this again, so if I call G again, so G, so maybe I call next G to see what's going on. So if I call next G and it's, oop, oh yeah, it's actually expecting a, it's expecting, yeah, I think it's expecting something to come back here, so I can't call it like this. So what I have to do is to call g.send, and then let's do it 10, okay? So see what happened. And I'll just run this again just to refresh the whole thing. And yeah, it will stop iteration because when 10 is come back here, so remember here we're like here, we're waiting for another send. So we stand in the 10, so number is 10, and then now 10 plus 1 is 11, so 11 is, well, it's greater than n, so it will just like, okay, so it won't go into the loop, it will just like finish the whole generator, and then it will just stop iteration, okay? So this is how you stop an iterator um, from going forever. But actually, every time it hit yield, it will stop. So it's, well, you can actually have it run forever on purpose, but that's actually what we are going to do in async actually. Um, so is there any questions so far about this? First, if you type in the chat, that would be great. I'm looking at the chat at the moment, even though my internet is a little bit, unhappy today, but I am actually looking at it. So yeah, type in the chat if you have any questions. So um, yeah, so let's go back to here, and so the next step is that when it goes to, because this yield is, all these things is like there for a long time, since once upon a time, right? So I think it's even from Python 2 it got this. So if I'm wrong, please correct me. So I think Python 2 you also got that, but Python 3.3 it got this yield from. So what yield from lets you do is that it will actually let you to chain all the generators together. So yeah, last time I don't have a good example. I just point you to a post. So this time I found a good example here. So maybe I'll just show you this here. So so we have 3 generators. So they're all like, they have yields. So they're generators, not functions. And some of them are yield from. So what it does actually is link them up together. So top is actually linking from middle. So it's like, so every time when it hit here, it will just like wait for middle to, it's like, because it's a shorthand, right? Remember our slice is a shorthand. So it's kind of like, it, if you expand it, it's going back, to this, it's like going to the generator 2, because item in generator 2. So it's actually passing it to generator 2 to give me back stuff. So that's the item. So every time it hit another generator, like yield from another generator, so when it hit here, it's actually passing it to the other generator. So it's a very good shorthand to write the code. So it's kind of like passing a ball around. So you're just like passing things around instead of instead of just writing that for loop thing. So my computer is dead. So I'm looking at my phone right now. So hopefully things are still okay. So yeah, okay. So um, let's run this actually, so we can see what's going on. So but before that, we can see that, well, actually we didn't call middle and bottom, okay? So it links up together from top to middle, and then middle is linking up to bottom. So this one is actually like top is expecting to get something from middle. Middle is expecting to get something from bottom, okay? And so yeah, you can see that the comment is like, it actually is like chain reaction that is calling, expecting things to go from each other. So here we generate the generator of top. So we have it, and then we just connect on it. So what we get here is that because when you connect, it will actually start the journey, right? So um, so it says that it will print 42. So maybe I can comment this out and see if it prints out 42. Yes, it does print out 42. So what it does is that it would go, from top when you call it the next, it would go to you from middle. So it's kind of expecting middle. Do you have something to pass to me? And then middle is like, oh yeah, okay, sure, let me check. It's like, okay, bottom, do you have anything to pass to me? And then bottom is like, oh yeah, yeah, sure, let me check. So, oh, I got a U42. Do you want that? So, and I will pass to middle, and middle is like, so this is U from bottom, so it's kind of go through this first, and go through it, and then it's like U from 42 is like, yeah, 42, okay, here you go, and it will U back to top, and it's 42. It's like, okay, 42, and then top will give back 42 as the value here. So we'll print out 42. So let's uncomment this and see what's going on. Oops, sorry, I deleted it. Okay, see what's going on here. So this time I send a values time too. So value is 42 here, right? So I send it to. So remember. So the thing is like we have to remember the state of what's going on here. So now we are stuck with this dude here. Okay. So and we are saying like um you know send the value to send 42 times 2 in, so this is like 84. So well, you send it in, and then it's just like here will become 84, so it's just like returned it. And yeah, so this is like not very obvious, right? So like what's going on? Maybe I could can I print something out? It's not that obvious. Yeah, because like then it's just like returning 84. But if I could, yeah, I think this is a very good example, but it's lacking the transparency within. So can I change this to 12? So yeah, it will become like 24 because it passed in this value in here, and I will just give it back because it's done. It's done with everything, right? So it's just returned it. So, but if we, how about like let's try to exhaust it to see like if it will just like give back the value um from it. So let's see if we can exhaust it actually. So what if I do this again? What will happen? And 42, 42, 84. So, oh yeah, because I generated again. Okay, sorry. Let me see if I can. Yeah, it will stop iteration because when I call the next, actually it's already exhausted here in, yeah, so it's already exhausted because it's stuck here. So when you kind of, yeah, when you're just like, oh, please give me a next, it doesn't have another U, so it would be returning nothing and it's stuck. So it's like stop. And yeah, so that's the example of like how you can use yield from. You just chain them all together, okay? So why is that important? Because it kind of provide a idea of, oh, wait a second, I can chain things together. I can, pass things from this one to another one. We can have async. so, um, so yeah, Async Io is coming in from Python 3.4, and there's event loop and coroutine. I just do a hands up coroutine. Yeah, I just found it funny. Because I will explain it. What is it? So, event loop. So it's a loop, and what it does is actually it's a loop. It's funny because like it's not looping. So some event loop actually will it will exhaust itself. So when it got exhaust, actually it will stop. But also there are also loop that runs forever. So it's truly a loop that's just doing it again and again and again. And so what it does is like it will have the task register. So you can say like, okay, event loop task A, B, and C. So you take care of them. I give you those tasks. And then actually event loop will be like orchestrating how all these tasks are doing things. So because some of them will be like pausing or giving the control to another event, so the other event go, and then because event A is waiting for the answer from event B, so event B, please, do what you need to do, and then event B say, no, 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 I have to pause here because I need something from event C. So it's kind of like uh, the top, bottom, top, middle, bottom kind of layer like that. So So, but we don't have to write all these like chaining of generators. Actually, we can just create this loop. Okay, so this is this kind of like the standard. So it's like a task manager is kind of you know it would see when the other task is pausing, so it would orchestrate the other task to run. So coroutine is very similar to a function, but the thing is like this, because a function is that when you execute it, it would just like run until you stop. So coroutine is a little bit like generator. A generator is like you can have use from, and use from is like I would just stop there, right? So it's like a YouTube video. I would say that because you can you can pause it at any time, and actually you can resume at any time. So it's good for multitasking. So actually, generator is uh, is is actually a coroutine if you think about that. You can, with the especially those with the send, you can actually send things in it. It'll pause whenever you hit the yield. So so yeah, so it's different from a function that you just run from top to the end until not to the end, but until you hit return, and it just like return, done, forever. Um, so so this is how this actually continue. Then we have Async Io in 3.4, so things would be kind of like this. So let me copy this and run it. So by the way, all this example here is actually from a very, very good article by one of the C Python core developer. I will show you the link at the end. And great, applause to him because it's a really good article and I learned a lot from it. So let me actually I don't want it to stop iterations. Let me go back to this. Okay, so what I gotta do now is I gotta do the async IO. So yeah, here and yeah. So we have this, and you see that actually we have this decorator here. So async IO actually is introduced in 3.4, and then it's actually is a standard library. So it's those battery included libraries. So it's installed when you install Python, but it's not always there when you just write any Python script. So you have to import it still. Um, so is well, when you have async IO, there's actually a coroutine decorator in there that's actually help you to write a coroutine. So you can see that actually this is a generator. Well, it's just that when we put the coroutine here, we make it become officially a coroutine. I would say that's so you can use it together with other async IO thing. So you can pass it to the event loop. Okay. So you can see that actually, yeah, the generator, the structure of a generator actually is a coroutine, but it's just like we have to declare it to be a coroutine, so it works with the event loop here. Okay. So this is actually just counting down, but it will sleep. So it will just sleep for 1 second. I do believe that so when you could create two of them that is counting together, that would be funny. Okay, not funny, but interesting. So not necessarily funny. I found a lot of things funny, but yeah. And so you can see that we are using the event loop here. And oh, there's one. No, that isn't any comment. Okay, I'm seeing ghost. So yeah, please comment. Please let me know that the stream is working fine because um, I'm not seeing my stream fine on my laptop. I don't know whether it's me or is it. So I don't know whether it's my streaming computer or is it because of my watching computer. So let me know if that's okay. Uh, yeah, because I'm really concerned that it may also ruin the recording if the streaming is not coming in properly. So yeah, let me know if anything's go wrong because I can't properly monitor myself. So okay, back to the event loop. So in Async IO, you can also find this get event loop. So it will actually return an event loop here, and also you can ask the loop to run until complete, so it doesn't go forever. And at the end, you can close the loop. So this is all in Async IO. I forgot to put the link of the documentation of Async IO in the slides, but we may have a look afterwards if we have time. So yeah, so let me see what. Okay, so how about let's try run it to see what's going on. Okay, so it's running. So you can see that. Okay, let's do it again because yeah, the loop is already running. Yeah, it's a bit weird if I run it in the Jupyter Notebook. I think because yeah, I think because maybe it's using a yeah, maybe Jupyter Notebook is also using an event loop. I don't know. Like it's just yeah, it's just make things a little bit weird if I yeah if I like run it here. But you can see this is working, right? So let me run this again to see if we can see that again. So yeah, you can see that both of them. So if you don't do it with async, right? If you just call this, if I copy this script and call it like this, okay? If I it's not a coroutine and it's not well, it's just an iterator, okay? So I can just if I don't okay maybe it's like too much work. Let me see. Yeah, I don't have the event loop. I don't do async here. I just don't want to do async. Okay, let's just make it this generator, and I don't have all these things. Okay, what I gotta do here is that I just going to countdown a. So for example, if I want to for item in countdown a, and then pass, and then for so if I just like run these two things not in an async kind of way, you can see a difference of it. So here I think I have one more. Yeah, it's too much here. So if I run it like this, yeah, you can see that it's running everything. So I should actually print out item here. Yeah, it's too fast because I'm not really sleeping properly. Routine. Yeah, I can't use this sleep here. So I need to use the there's another thing. Yeah, there's another thing in the sleep that you could actually do. I forgot what it is. Sorry. Yeah, or pause or something, or do nothing for 40 minutes. But I think there's a sleep method. Yeah, time. Okay, time dot sleep. So instead of async, I do time. So time dot sleep. So yeah, now you can see that is oh, I haven't deleted the code properly. Is it? Oh yeah, I haven't deleted this. Sorry about that. Non-type is not iterable. Oh, yeah, maybe I just like uh, yeah, I don't know what's like item print item maybe. Yeah, I can't just or maybe continue. Yeah, sorry, I'm lack of sleep, so I'm not very sharp. Sorry about that. It should work now. No. Oh, why it become a non-type? Oh, because it doesn't. Oh, I deleted the yield from. Is it? Ah. So yeah. No, can't even spell. Yep. Yep. So it's just a generator, and we're just looping through them. And well, yes. Well, why is it still? Oh, because yeah. So this is just using an iterator, but you can see that it just do A first, and then it would do B. Okay. So it's different from async that actually A B are doing things at the same time here. Okay. So yeah, this is the point I want to make. Is it big enough to see? Yeah. So this is async, right? A B A B B. This is not non-async. It's just a loop. So A A B B B. Okay. So if you want to do something like that, you have to do async. And what it does is that you have to make it a coroutine. The first thing. So instead of just a generator, you make it a coroutine. And then you create an event loop, and then you pass all your tasks in the event loop here. That you can tell the event loop to run it until you finish, all of them are exhausted. So if all the tasks are finished, then it will just, done, and then you close it. So, I mean, done is like it will run this next line, which is closing it. So, yeah, lots of things in Python need to close it. Otherwise, like, there's a risk of leaking it. That's just like stay open there, just stay there forever. So you don't want that. So you have to close it. And yeah, so that's Async Io, and actually we can have a look at Async Io Python Async Io. Of course, it's not 3.4 that we're looking at because latest is 3.8. So 3.4 is outdated now, but the concept is introduced at that time. And my internet is just super slow. Are we still streaming okay? I think it's, yeah, it gives me an orange. Sorry about that. I think yes, I streamed too much from the conference, and because I was watching all the conference and stuff, so maybe like my internet provider is switching me off because I used too much of the bandwidth or something. So yeah. Mm, right. So hey, come on. But this is not what we are ultimately talking about today. We still have the async in a way that's coming up soon. It's too slow. I would maybe post the link afterwards, and we can come back to it when we have time afterwards. Okay? It's taking too long to load. Um. So yeah. We have this. This is what we were talking about, F3.4. It's also available till today. So it's like available 3.4, 3.5, 3.6, and towards 3.8. But 3.5, we have something new. We have the async away. So it just makes this even more, even smaller. And the funny thing is that in the article that I will show you at the end, actually, um, you can use both in parallel. Actually, it's just it won't mix together. It's very interesting. But I won't go into the detail here. But yeah, the difference for 3.5 is that you can have make a function async, and then you just instead of you from, you just do away. So I think this is one of the challenge that I want to challenge myself. Can we rewrite our code with async away? So I think the first code that we have here, maybe not this one. So let's see if we can write this with async and away. So so what we want to do is to have this counting thing asynchronize. So I don't know whether I can do it in Jupyter Notebook to be honest, but let's try. So um, so usually you will have we will have this function here, the coroutine, not function, sorry, coroutine here. So I just copy it and put it here, and then this one would be an async function. Not async async coroutine. Whoa. Okay. So and then here we have away instead. So now if I pass this to the event loop, so it should still work. Not this one. Here. Yep, it's still working fine. So it's just you know, it's easier. But well, yeah, like you can still use it together with Async IO. This is not really showing much um difference. It's just like make it nicer. But actually, it's very good, um, improvement. I think that you don't have to, it's kind of you can see that it's getting rid of its trace from its like become, it's go from the generator and yeah, and oh, it's here now. Okay, so um, async IO. So this is it's the coroutine here and task and stream. So all this. So I think, yeah, the event loop future. So let's look at event loops. Oh, it's gonna take forever to load, is it? Not good. Okay, so yeah, so all this actually is from this blog post here. So it's really, really worth the reading, I would say. Oh my god, my internet is super slow today. I'm sure that my streaming is horrible. um, so yeah, please read this blog post. You will have the link, and so this is all the information is from, and you can see that it's explaining everything very clearly, and um, yeah, and all this. Yeah, I won't go through, but like there's a section at the end that's worth noting is that it explains in bytecode. So this is like actually how like this is actually breaking down the Python code into something closer to a machine code, I would say. um, but not exactly machine code, but like you can see this is very raw like code. We call this spy code. So it's just laying out all these like your Python code into steps. Okay, so you can see that using 3.4 and 3.5 actually it makes a difference because within the internals of Python it will tag things differently. It will check, whether it's like a, whether you can still see the traces of it being a generator in there in the 3.4, and the 3.5 is actually, well, it's awayable. So away in 3.5 make things into a new type is called awayable. So awaitable. So yeah, so it you just like can kind of get rid of all the traces of it being a generator in general. So um yeah, so that's it. And I guess people are busy at EuroPython, is it? so so yeah, another thing is that the Discord board that I built for EuroPython, the register board, actually Discord.py uses async as well. So you can see that like when you deploy the board, actually it will run forever, and you can have different events that when someone send you a message or type a command, then the board will respond. So it's kind of like, uh, of course, it need to be async to be listening to the events and stuff. So let's see if we can look at the event loop. Yes. So the event loop. So you can get a running loop, and that is, yeah. So it's just like it runs forever, and uh, so oh no, it's getting a loop that's already running. Okay. So this one is get a new event loop, I think. Yeah, there's no current event loop. Yes, this one need to be like no loop in your OS. So I think the problem that I get that error in the Jupyter Notebook because maybe Jupyter Notebook is also using async, so you get the event loop already running there. So yeah, so that's why it's complaining somehow. So there's not. So yeah, there's like some error will be raised, and so I don't know whether I can change my coding to get running loops so to see what's happening. So let's try. Let's ruin things. What could possibly go wrong, right? So let's go back to our code here. Let's get running loop. No, it's even already running. Oh, what is like? Oh, it's like run until complete. Okay. Yeah, so that thing is not happy. So let's have a look at that function maybe. So we have set event loop, new event loop. Yeah, so it's all this stuff. So what's that? Run until. So it's the loop object, right? So I want to have a look at the events. So maybe I can search it. Now what's that? Again, run until complete. Okay. Yeah, I can see that there's actually a lot of fun doing that. This async. I think it's make a lot of application. It's very useful for a lot of application, especially if you have like user interface and things like that. So run the until stop is called. So I've never called stop. I think like it may be called somewhere when the thing is done. I think. So yeah, I'm still new to this. To be honest, I'm still learning. And yeah, I wish I have more time to prepare for this because yeah, I was busy with your Python, so it's a little bit shallow today. Sorry about that. Maybe we can come back to this in the future when we talk about this Discord of Pi or something like that. Yeah, I think I'm just gonna continue the story that we started 2 weeks ago, and we go to this async thing. But you don't have to understand too much actually to use async. I was doing fine when I write the board, but I guess it's good to understand all these. I don't know when I'm gonna use it like properly though, but I think it's really fun. Okay, so I will put all this link back into the slides on top of this like this amazing blog by Brett Cannon So like I said, this episode will be a bit short because it's EuroPython, and I don't want to spend too much time away from it. I have a lot of things to do. I had a very very busy week, and yeah, I'm a bit like of shape. So I hope you enjoyed today's episode still, and so next week I would be like more awake and more sharp, and we'll talk about the doc strings magic. So there's a lot of tickets issues that we work on today at the sprints. They are about the doc strings. So it's about the docs and stuff. So I think it's good to make a tutorial to explain Spanx, how Spanx work, because beginners may not know that, and what's the style of the doc strings that's like that people write, and what is a dog string maybe. So yeah, I gotta explain all this, and maybe Pie's gonna be resuming, I think, but we doesn't have a guest yet. Yeah, I have to talk to Lace about it. We need to get a guest soon. So yeah, so and hopefully, according to the plan, we will resume Meet with Pie the coming Wednesday, and Monday I still have the data science tutorial. We'll go into logistic regression, some like basically categorical like prediction, things like that. And yeah, I think that's it. Sorry, today's episode is super short. I think it's pushing both my limit and the technical limit because the streaming is super bad. But hopefully things will be normal starting tomorrow, and I will see you soon. Bye.